Okay, so I'm just going to talk through a quick question about using graphs to solve equations. This is a very typical kind of paper 4 question on the extended syllabus. So here we go. First off, complete the table for the function x cubed over 2, take away 3x, take away 1. And we've got some spaces missing. So this should be pretty straightforward. All we really need to do is to just remember to use the brackets on the calculator. So this first one for minus 2, as long as we put the minus 2 in the brackets, minus 2 cubed divided by 2, take away 3, open brackets, minus 2, close brackets, take away 1. The calculator works out the answer as 1 for us. Okay, that's pretty much the only mistake we can make on this first part of the question. Equally with the second one, when x is 0, we put 0 into this equation, 0 cubed divided by 2, take away 3 times 0, take away 1, we get minus 1. And then for the third one, we get 3.5. Okay, so 3 marks, as long as we remember to use the brackets, should be quite straightforward. Okay, the next bit, it asks us to then actually plot the graph between minus 3 and 3.5. So we basically just plot these values here. It's a little bit difficult on this one because I've shrunk down the scale, so it's going to be slightly approximate. But you can kind of see how it works. When x is minus 3, that is going to be minus 5.5. When x is minus 2, we've got 1. And we basically get this kind of shape here, which is what we would expect for some kind of cubic equation, so something with an x cubed in it. So there we go. So we've got our graph plotted. The next thing we need to do, it says solve f of x equal to 0.5. First off, remember what f of x was. So it basically said f of x was this function here that we've just plotted. So what this is saying is we want to find when is this function here basically equal to 0.5. And really, if you want to think about it, you can kind of think about it like this. So this is the function that we've plotted, and actually what we plotted was y equals x cubed over 2 minus 3x minus 1. That's what we plotted already. And then on the right hand side we've got 0.5, and actually what we're looking at is plotting y equals 0.5. So in effect what we do is we draw the line for y equals 0.5. That's going to be this horizontal line here, and then we solve it. When are these two things equal? Well, they're going to be equal when there's an intersection. So we basically look at this point, and this point, and for each of them we need to say what is the x value when they intersect. Okay, and if we read off the graph, we should get something that's around about this. So minus 2.2, around about minus 0.5, and about 2.6. So we have 3 possible answers. If it had said solve f of x equal to 0, then I'd be looking at this point here, and this point here. Okay, so that's kind of a typical sort of question. Okay, this is a bit more difficult. It says find the inequalities for k such that f of x equal to k has only one answer. Now remember what this actually meant was we basically drew some horizontal lines for y equals k when we chose different values for k. So for example, y equals 6, I would draw the horizontal line across here. Well, you can see that that's only got one solution. If I drew the line y equals 5, that would be there. Again, that only has one solution. If I drew the line y equals 3, again there's only one solution, it only hits this one there. But if for example I draw the line y equals 0, which is this line, you can see it intersects 1, 2, 3 times. So basically I want to know what values give me only one possible answer. Well, I'll kind of think of it like this. My horizontal line for all of these values all the way down here is only intersecting the graph one time. And the boundary line is this kind of dotted line here. As soon as I get below this dotted horizontal line, it's going to start intersecting the curve more than one time. And equally, if I get lower than this boundary line, I'm going to start intersecting the curve only once. If I go above this boundary line, I start intersecting the curve more than once. Okay, so that basically gives me the two boundaries. If k is less than negative 4, so there's my negative 4. If k is less than negative 4, I'm only going to intersect one time. And equally, if k is greater than 2, I'm only going to intersect one time. So that's my answer for the second part. And then the very last one, it says draw the graph of y equals 3x minus 2. Well, to do that I'm just going to use my little grid, choose some values. When x is 1 I get an answer of 1, when x is 2 I get an answer of 4, when x is 3 I get an answer of 7. So I plot my straight line graph, and then okay, very similar to the last one. I've basically, if you think about this thing here, this was basically the graph that I've already plotted, and then this here is the new graph that I've plotted. So I've plotted y equals 3x minus 2. So when are these two things equal? Well, they're equal when they intersect at this point and some point down there. And it says the positive answers. So I'm only looking at these two answers there. Well, at this point here, I've got around about 3 point something, about 3.3. And at this one here, it's pretty close to 0. It's a bit hard to see on my scale, but I say it's roughly about 0.1. Okay, so I've got two positive solutions for when my original curve intersects the line that I've just drawn.